All right, let's make sure. All right, if you have anything in your calculator, make sure you clear it out. We're just gonna, it's pretty easy. We're gonna compare linear, quadratic, and exponential. And you already know how to do a good majority of it. We're just gonna refresh, and then I'm gonna teach you how to do the quadratic and exponential in the calculator. We've already done the linear in the calculator this week. So we're going to figure out from equations, from graphs, from tables, whether they are linear, quadratic, or exponential. Okay, and then next week we'll do real world problems on then deciding what they are. All right, so let's just refresh really quick. A linear equation has an x with no exponent. A linear equation's in slope-intercept form, so it should be in y equals mx plus b form. Remember, the couple important things you need to know is you need to know your m, which is your slope, and your b, which is your y-intercept. These examples right here are all in slope-intercept form. Well, I shouldn't say they're all in slope-intercept form. They're all linear equations. What form is this last one in? Who remembers what form that's in when x and y are together on one side? Anybody? Standard form? So all of these equations are going to be linear. These first two are in slope-intercept. The last one's in standard. If you ever doubt whether equation is linear or not, you could put it in your calculator. So like that third one, if I doubted whether that was linear, I can put it in my calculator and I can see linear is going to make a line, and it does make a line. I can kind of zoom around if I need to make sure it fully makes a line. A quadratic has an x squared in the equation somewhere. So you can see all these x squareds here. Remember, a quadratic is always in the form y equals ax squared plus bx plus c. A, b, and c will be some type of numbers. An exponential has an x as the exponent. So you can see in all three of these, you have an x as your exponent, so that's going to make an exponential. The equation for exponential is y equals a times b to the x power. Remember, with an exponential, if your b is greater than 1, it's going to be a growth. If your b is less than 1, it's going to be a decay. Your a, whoops, looks like I put that from a, but it's for your b. Your a, I'm going to move this over here, is called your initial value or your y-intercept. All just refreshers from what we've done so far. And again, on the exponential, this last one doesn't look like it's in exponential form because y is not by itself. You could plug it into your calculator just to double check. And you can see that it kind of makes a decrease. So that's just identifying it from an equation. When in doubt, if you feel like you can't tell from an equation, just go ahead and put it in your calculator, see what the graph does. The graph of a linear is going to make a straight line. The graph of a quadratic is going to make a parabola. And the graph of your exponential is going to make that smooth curve, whether it's increasing or decreasing. Everybody got all that part down? All right, so let's identify these 4. Tell me whether you think linear, quadratic, or exponential. So look at that first one. What do you think that first one is? Look at that first one. Oh, what? Why do you think linear? It's not linear. What do y'all think it is? What do you know? What's the big thing that you noticed there in that first equation? What is your exponent there? X. If your exponent is X, which one is it going to be? Exponential. What about that next one? If you have an X squared, is that going to be linear, quadratic, or exponential? Quadratic, good. Look at that third one. That just has an X. It doesn't have an X squared, so it can't be quadratic. It doesn't have an X as an exponent, so it can't be exponential. So therefore, it's got to be linear. If you doubted yourself, put it in your calculator to see what it makes. This last one, the exponent is a 2x. If you have an X as your exponent, that automatically is exponential. Now let's refresh on graphs. So identifying from a graph. Remember, linear is going to make a straight line. Your straight line can either increase, which means it has a positive slope, or your straight line could decrease, which means it has a negative slope. But linear is going to make a straight line, whether it increases or decreases. Quadratic is going to make a parabola. Remember that U shape is a parabola. If it faces up like this one does, what's that called when it faces up? What's this point right here called? Called your minimum vertex point when it faces up. If it faces down, it is called a maximum. It's a minimum vertex point when it faces up. If it faces down, it's a maximum. And then your last one is exponential. It rises or falls quickly in one direction. This one is called an exponential what? Is that one increasing or decreasing? You should be able to tell that it's decreasing, so it's called a decay. If it increases or rises at a quick pace, that is called a growth. And remember, we just talked about that's based off of your B value. Telling from a graph is really easy also.
Gentleman in the blue shirt over there. Bring it back. Can you bring it back that way?
All the stuff.
Yeah, bring all your stuff.
Bring all your stuff, just not my computer.
All of it?
Yeah,
Yes.
just bring your. Yeah, just you. If you're good, you'll come back. Just pack up everything.
Come on. All right. So look at these graphs. Let's decide which one they are. So this U that faces down, what is that? Is it linear, quadratic, or exponential when it's a U? Quadratic because it makes a parabola and it faces down. So when it faces down, there's going to be a maximum. This scatter plot. What do y'all think that scatter plot is? Very good. It's exponential. And do you think it's going to be an exponential growth or an exponential decay? Okay. Very good, because it decreases. Exponential decay. What about the third one? That clearly is a linear. Is it going to have a positive slope or a negative slope? Yes. Why is it going to have a negative slope? Because it decreases. Very good. So that all should be the easy part. The next part is not that it's hard, but it's just that we have to be able to identify through a table, and then we're going to have our calculator write the equation once we decide whether it's exponential, linear, or quadratic. Okay? All right. We good? All right, let's look at our tables now. If it's a linear table, you're never going to see the same y value twice. And the first difference is the same on the y's. Add that in there, on the y's. The first difference is going to be the same on the y's. So it's really important for us to check our y-axis when we're deciding whether it's linear, quadratic, or exponential. So if I check my y-axis, the difference here, what is it doing from -1 to 1? What is that difference? Adding 2, good. What about 1 to 3? What's that doing? Good. Whoa. What about 3 to 5? What's that doing? All right, so the first difference all the way through is the same. When that occurs, it's a linear function. Now you can write the equation for that table. The calculator is going to do all of that for us as long as you put the right stuff in. So if it's linear, this is what we would put in our calculator. We're going to put our table in, and then we're going to put our y1 squiggly mx1 plus b. Which is what we did the other day. So that part you've done before. So let's clear out anything you may have in your calculator. Go ahead and hit the plus sign for your table, or hit the plus sign and then go to the table. Put in your X's and then put in your Y's. And then once you put in your table, it gives your scatter plot points. It plots your points there. And you can tell it makes a line, right? Anybody have an issue with that so far? Now we're going to tell our calculator, write the equation for us. So in the second spot is where you do your y1. Does everybody remember where to find that squiggly? Shift and then to the left of the 1, mx1 plus b. You see how it makes your line of fit right through those points? And now we can write it. Scroll down, you see your m and your b. Write my equation. So my equation is y equals 2x plus 1. If you want to double check yourself to make sure you're right, in the third column, you could put whatever you think the equation is. And if it is correct, it's going to just go right over the green one that you already had. So that one's easy. That's what you already know. The other two, not that they're hard, but we just have to learn how to figure them out.
Thank you, Mr. Chester.
Hi.
Have a good day, Mr. Florida.
Yeah. Oh, he said you know. He doesn't want to have a good day. All right, let's go ahead and look at the quadratic. So quadratic, when you're given a quadratic table, you're going to see the same y more than once. This time, the second difference is going to be the same on the y's. So I'm going to show you how that second difference is going to be the same. First of all, we see the same y more than once. So let's check. What happens when I go from 1 to 0? What's the difference there? So you're minusing 1. 0 to 1, you're adding 1. So I'm checking the first difference. 1 to 4, you're adding 3, and 4 to 9, you're adding 5. The first difference clearly is not the same, right? So it's not linear. The first difference is usually checking to see if it's linear. If it's not the same, check the second difference. What am I doing to go from -1 to +1? Add 2. What about +1 to +3? Add 2. +3 to +5? Add 2. When your second difference is the same, that's when it's quadratic. Now, yeah. In a sec. Now, let's tell our calculator to write a quadratic equation. So we have to put in a little bit different for a quadratic. When you do a quadratic, it's y1, squiggly, a, x1, and you need to square that x1, plus bx1 plus c. And that is going to give me the number that I need for my a, b, and my c in order to write my equation. So clear everything you have in your calculator from the other question. Add a new table. Put in your information for that new table. And once you put that new information in, you can kind of see that it's going to make a U. It plotted my points. It's going to face up. And now tell your calculator to write your equation. So y1, squiggly, a, x1, and then you need to square that, plus bx1 plus c. And you see how it makes me my parabola line right through those points. And now I just need to scroll down to see my a, b, and c so I can write my equation. So y equals 1x squared plus 2x plus 1. And you got your equation for that quadratic. So there's really not much you're doing but deciding what type of function it is by checking the table, and then the calculator is going to do the rest for you. All right, let's do the exponential one, and then we'll try some examples out. So exponential means there's going to be a common multiplication pattern in the y. Also, you will never see the same y value twice. So if I look at my y-axis, I don't see the same number. What do you think the common multiplication? First of all, are your y's increasing or decreasing? Increasing. That means whatever you're multiplying by has to be bigger than 1. If it was decreasing, it has to be less than 1. All right, so what do you think I'm multiplying by every time on my y? By 2? All right, so if it's multiplication pattern for your y, then it's going to be exponential. So that goes in the calculator like this. That goes in as y1 squiggly a times b to the x1. So let's clear out everything you got in here. Add a new table, put your new points in. Whoops. And then we can find out our A and our B so we can write our equation. So it plots my points for me. I can kind of see that's going to be a growth because it's going to increase. Uh-oh, what am I missing? Oh, I forgot the 16. Make sure you got something for every spot. Everything matches up with something. And then tell your calculator. I know it's exponential, so let's write it. Y1 squiggly a times b raised to the x1 power. And it makes your line that goes through your points. And if you scroll down, you can see your a and your b, so you can write your equation. So y equals 1 times 2 to the x. So not too hard. The biggest thing is going to be for you to check your differences there to see whether the first difference is the same, it's linear, the second difference is the same, it's quadratic, or if it's multiplying by the same number every time, then it's exponential. Bye, go cookie. All right, let's look at some tables to see if we have any questions on that. Are we good with our calculator? All right, let's look at some tables to see if we can figure out what they are, and then we'll use our calculator. Our calculator does pretty much everything for us. Let's skip 1. Let's skip 2. Let's jump right to 3. Everybody see 3? All right, so I'm giving you 3 tables. Let's decide, are they linear, quadratic, or exponential? And then the calculator will write the equation. All right, so look at the first one. What's going on in the first one? The easiest thing to check is your y's. Look at your y's. Are they multiplying by the same thing every time when they go from one to the next? Clearly not, so it's not exponential. So then I'm checking my differences. What am I doing from 5 to 9? Isn't it 4 again, and 4 again, and 4 again? When your first difference is the same, what type of function is it? When your first linear, very good. And once I decide that, don't forget, the calculator does it. So clear out anything you may have there. Make a new table. And you can tell, scroll around, see your points. I can tell they're linear. How do I make my calculator write the equation? What do I put in? You can refresh me. Remember, y1. Put your squiggly, not the equals. mx1 plus b. And then yes, James, it's going to look like y equals, good. And once you have your m and your b, y equals 4x plus 1.
Y equals 4x plus b.
That's when you're writing your equation. When you're putting it in your calculator, you're going to use that little squiggly because it's just what the calculator uses. That's their denotation. But yes, when you write it, you'll have an equal sign. Okay? All right, next one. So the easiest thing to check right away is if it's exponential. So look at your y's. Am I multiplying by something? Can you easily tell if I'm multiplying by something for my y's? No. So it doesn't look like it's going to be exponential. So let's check our differences. What's going on from 0 to -1? What's happening there? You're minusing 1. -1 to positive, which is 0, is adding 1. 0 to 3 is adding 3. 3 to 8 is adding 5. So if the first difference is not the same, what can it not be? It's not linear. So it's got to be quadratic. Let's check the second difference. From -1 to +1 is +2. +1 to +3 is +2. +3 to +5 is +2. So it is quadratic. The calculator will do the rest for me. Put it all in. Oh, and if you also looked at the y, you notice you see a number twice. Quadratic is usually going to give you a number twice. So that it plotted my points, and you can kind of see that's going to be a U shape that faces up for my parabola. Now, tell your calculator to give you your equation. So for a quadratic, it's y1, squiggly, ax1, and square that, plus bx1 plus c. There you go. You get your parabola that goes through your points. All you need is your a, b, and c. So write your equation. So y equals 1x squared minus 4x plus 3. All right, last one. So look at your y's. The easiest thing to tell is if it's exponential. Are you multiplying by something every time on those y's? What do y'all think? What's it doing to go from 3 to 9? What's it doing 9 to 27? Multiplying by what? 3 to 9. What am I multiplying 3 by to get to 9? 3. If you do 9 times 3, you get 27. If you do 27 times 3, you get 81. So and 81 times 3 is 243. So you're multiplying every time. That's exponential. So let's go ahead and put it in our calculator. Then we'll tell our calculator to write an exponential function. Clear out what you got. Add a table. Put your new points. It's a little bit harder to see with this one that it's going to be exponential, but you could tell from the table. It's just the graph makes it a little harder. So for an exponential, remember that's y1 squiggly a times b raised to the x1 power. And it makes your exponential line. You got your a and your b, so write your equation. So y equals 1 times 3 to the x power. want to be 100% sure that that's your equation, put that in line 3. The way you'll know is it literally will just put it right on top of the red one. Give me 1 sec, James. All right, any questions on putting it in the calculator? All right, pull up Google Classroom. Oh, let me stop sharing, stop that. This call is being recorded if you want to end the call. Oh, stop recording. Stop recording.